We're going to revisit our set theory as we look at intersection and union of geometric figures. To start, let's just do a review. We know that this symbol means intersection. You can also think of that as the overlap of two sets. And then this symbol, a nice big U, obviously represents union. Isn't that nice and easy to remember, the U of union? The union means that you take everybody, you just join everybody together. So here's an example. Here's set A. It has 1, 2, 3, 4 elements. Remember, elements we separate by commas and we put them inside these braces. And here's set B. So if we take the intersection of A and B, that would be written like this. And what would that be? That would be the overlap. So what do they have in common? Well, I see a 3 in both, I see a 5 in a both, so their intersection would be 3 and 5. Okay, now their union is going to be, I'm just going to take everything, so I'm going to take all of A, 2, 3, 4, and 5. I already have 3 here, I already have 5, so now I'm just going to add in 7 and 9. Notice I do not repeat elements. That is not something you do when you are listing the elements of a set. So now we're going to apply that to geometric figures. How is that going to work, you might ask? Let's take a look here. Suppose I have something written like this. Segment YZ that I'm showing up here in purple. What is that when it's intersected with ray YX? And that is being shown here in red. I highly recommend extending your figures to the edge of the figure as opposed to writing ray YX like this, and that helps prevent a lot of careless errors. So extend to the edges of the figures. Okay, so how do I figure out the intersection? One way to think of this is where, if I moved these two on top of one another, where would they overlap? And as you can see, they would overlap at Y, so that is going to be their intersection. So their intersection is Y. If I was asked what their union was, I would take this whole figure, and I would take all the points that I have in this figure that I've basically added these two sets together. And so my union of these two figures would be ray ZY or ray ZX. So let's look at this as an example. I have a half line, CB. So I do not have the endpoint C, but I have all of these points. Notice I'm extending to the edge of the figure. And then I have segment BC. All right, so maybe if I don't want to see where these overlap, maybe I want to see where, I call it the rain test, or a vertical line test. So where would a vertical line pass through both of them? And that's going to occur in these spaces. They do not both contain C, because I am missing C here. So they don't have that in common. So their intersection includes B and all of these points up to C. So you'd think it would be segment BC, but we don't want the endpoint C. So we're going to call this an open-ended segment. That is allowed. It's a new term, and you will find it occurring often in these types of questions. I could have also written an open-ended segment like this. Another situation you might find is a double open-ended segment, which, as you can see, has an open end on both sides. So it's a segment that does not include either of its endpoints. Now, let's look at another intersection problem. So half line BD. Notice I'm going to the edges of my figure. And then ray CD. Okay, so where do these overlap? Well, I could just use my ability of notability to overlap these, and I could observe where they overlap, or I can sort of eyeball that, but I'm seeing that they both have C and everything to the right here. And so their intersection would be, actually, ray CD. Cool. Let's practice again an intersection and a union. It seems like I'm using half lines an awful lot, but these problems don't require a half line, just must seem like that. So sorry for the redundancy. We have half line RQ. And then we have segment RT. Okay, what is the intersection of those two? Well, if I'm doing my vertical line test, there's no place that I could draw through both of those sets. I want to do R, but the half line doesn't contain R, so there is nothing that these sets have in common. There is no overlap, so I could also call this the null set. That is also the empty set. One thing you do not write is this. You do not put the null set inside the squiggly braces. All right, and finally, let's try the union. What is the union of these two figures? Well, it'd be if I just combine these figures together. So I have T, and I go this way, so it would be ray TR. I could also call that ray TQ, but it's got to start at T. Let's do just some final practice. Ray VT, open-ended segment TV with the open end at V. So what is the overlap there? What do they both have in common? Well, not V, but they do have T. So I'll have an open-ended segment at V. Now what about TM, ray TM, and double open-ended segment AT? What is the union of that? Okay, so the union of that is I'm going to take everything. So I have everything from here. I have T because that comes from my ray. I have all these points and then all the points up to A, but not including A. So I'm going to have a half line starting at A. I could call that half line AV or AT or AM, doesn't matter. But it has to start with a non-endpoint at A. Okay, and finally, segment AT intersected with open-ended segment VM with the open end at M. All right, so what do they have in common? They have this part in common, so I would say that their intersection is, I'm not going to put my dot on there. Their intersection is segment TV, also known as segment VT.